Thank you everybody for being here. So this is session 1B. So Sam gave session 1A earlier on provision and targeting for vulnerable population. So this is MD4SG mechanism design for social good tutorial. And the first session was on an introduction and on proxy means testings and community-based targeting. So what I'm going to talk about here is more on self-targeting and ordeal mechanisms. So, okay. So when you are trying to provide a good to a specific population, there are some possible errors. So first, you may award your error. You may award your benefit to people who are not eligible. So this is your type 2 errors. So they apply, they get accepted, and then they get benefits. And then there's type 1 error, which is the eligible individuals not getting benefits. So it's worthwhile here to separate this out to one, which is an eligible individual apply for benefits, and then they're rejected. And an eligible individual not even applying for benefits, right? So this is incomplete take-up. So we're going to talk about these three kinds of errors through this tutorial. Okay. So what I'm going to try to cover in the next 45 minutes is what is ordeal targeting and how we would be sacrificing productive efficiency, meaning creating dead weight losses in order to better target the group that we're interested in. I'm going to talk about situations where it works and then situation where it may not work so well. So how would cost shocks change what we think of as the baseline model? How what differences in technology that the rich and the poor have access to can change the baseline model, and a little bit on the curvature of the utility function. And then we're going to look at some empirical evidence from the experiment that Sam talked about earlier in Indonesia, the cash transfer in the Alada's 2016 paper. And then last, we're going to talk about something that looks like an ordeal, smells like an ordeal, but is actually productive. And this is productive complexity, right? So tons and tons of forms that is there because you actually need it. Okay. Okay. So what is ordeal targeting, right? Okay, so let's set this up. So as Sam had earlier, so we have we have types. So we have low types and high types. So here being the poor and the not poor. And then what the government wants to do is they want to give the benefit to the low types, but they can't observe the type. And so for this talk, we're going to ignore how we're going to balance this budget here. So we're not going to think about like how do we tax the high types in order to pay for the low types. So there are papers like Nichols and Zackhauser that has this taxation built in, but not in this talk. So let's think of the government program as something that is like this, right? So you have the program, you're going to give benefit B to applicants, and you give this benefit with some probability P where the low type, the poor applicants have a higher chance of getting it than the high applicants, right? So maybe you have a PMT like Sam had earlier or other kinds of tests so that applicants can be approved. So, okay, the problem is that the high types might still apply. So you get this type 2 error. And so you want to discourage the high types from applying by setting some application cost. So what's important here is you want to set up an application cost such that the high types are more taxed than the low types. So for example, you ask people to stand in line for S hours. So S is like the ordeal level. And so if you have to stand in line for S hours and you have a high wage rate, then this is more costly for you than if you don't have a job and they have low wage rate. So technically what should happen is that AH, the high type, should not be applying, and so you would be improving targeting efficiency that way. Okay. So some examples of that are like unemployment schemes might require an individual to come to the unemployment office during like 9 to 5 hours. So if you have a job, this would be costly. Other things would be the oportunidades test transfer in Mexico also have people apply in person to apply. And then there's a recertification process. And there are things like you have to attend monthly health lecture or other kinds of stuff where you have to show up. Right, another opportunity cost of time. Some other examples are manual labor requirements to receive aid in welfare programs. So there are the Work Progress Administration program in the U.S. Great Depression, where people built roads and built a lot of infrastructure, and there's discussion about whether or not this infrastructure was needed, and it was there so that people whose wage rate was, who are willing to do manual labor would be the one that receives this program. And there are other kinds of programs like this in developing countries. Okay. All right. So what is the problem with ordeal targeting? So first, the person that is applying for this program will have to pay the ordeal cost. So one, this may be a waste, right? Like just standing there doing nothing to stand in line is a waste, that weight loss. So you have to be sure that this is being balanced by better targeting. Another one is you're taxing the poor. So if this program is working correctly, then the poor will be applying, and so the poor will be the one that is paying this price. And the poorest might just look at this and say like, wait, this is too costly for me, and you completely discourage application among the poorest, right? So this is the type 1A error where you have low take-up. Okay, so let's kind of build this all into a baseline model, right? So someone would apply if they so I guess you guys can see my cursor here. You apply, so think about a 2-period model where in the first period, if you apply, you're consuming whatever income you generate with your ability minus the cost of the ordeal level, and that is increasing in your type, plus the probability of getting the income, the probability of getting the benefit given your type, and then a discounted utility of getting the benefit in the next period, or not getting the benefit, and so you're just consuming your income. Okay, so the probability of getting through the program is decreasing in your type, and then the cost is increasing in 0. So there's a typo up there. Okay, so if you don't apply, just consume your current period utility and your discounted future period utility. So if we put some simplification here to make things simpler, linear utility, and just like multiply the ordeal level with the types, then we could write the gain function as follows. And so if your gain is larger than 0, then you will apply, otherwise you will not. And then the gain is decreasing in type, and the gain is also decreasing in ordeal level. So here, if I draw this gain, the dark line there would be if you have a low level ordeal, and then the light line would be if the ordeal is increased. And what you could see is that increasing ordeal increases the threshold type. So I'm better able to separate the poor and the rich by increasing my ordeal. Okay, so if I look at the probability of applying, then what I have on the green lines, which is the poor, is that I don't change the probability of applying among the poor in this case. But what I'm changing are the red areas, which is the probability of applying among the rich. And so by increasing ordeal, I'm improving targeting efficiency because I've increased the ratio of the application that is coming from the poor, the probability of applying from the poor versus the probability of applying from the rich. Okay, so this is one instance where increasing the ordeal helps targeting. Okay, so we talked about a situation where it works. So now let's add some more realism to the model and see whether or not it continues to work. All right, so I'm going to try, so this is from the Alatas paper as well. So basically in my talk, I'm going to talk about 2 papers here, the Alatas paper and the Clevin-Kowalczuk paper. So here, for cost shocks, let's think about a cost shock that you experience when you apply for a benefit, right? So for example, you might, when you stand in line for benefits, you might have a child. And if you have childcare, your neighbor comes over and say, I'm going to take care of your child for you, then your cost shock, then you have a positive shock, which makes you more likely to apply. And your child gets sick, you have a negative shock, right? So you're less likely to apply. So let's suppose that this shock, which the person observed when applying, is distributed with CDF F means 0 variance sigma squared. And then so what I'm adding here is I'm just adding the epsilon at the end of my utility function that you saw earlier, right? So this shock only happens when you apply. So now my gain function just have an extra epsilon in it. So I can now write my probability of applying with the CDF F. So my probability of applying is now 1 minus the CDF of getting a shock, the cost shock, that is smaller than the negative gain function. Okay, so now I can rewrite when increasing ordeal will improve efficiency. It will improve efficiency when the ratio of this 1 minus CDF for the low types and the high types is increasing in ordeals. Okay. So this happens depending on the distribution of the shocks. Specifically, when the distribution of the shocks have the monotone hazard property, meaning that the marginal, the ratio of the marginal type and the inframarginal type is increasing in the person's income. So, for example, if I increase S, I'm going to increase the number of rich people that drop off, the marginal people that drop off, rather than the poor people that drop off, then this will improve targeting, right? So this is true for uniform, normal, or logistic distribution, but not for like log logistics and other thick-tailed distribution. So if I compare the picture that I had earlier, where increasing ordeal with no noise, the no noise case that you saw earlier on the right side here, increasing ordeal does not affect the people, the poor here, but then affects the rich here. And I compare that with this case, where increasing ordeal creates a bigger gap here between the black line and the yellow line being the higher ordeal. Then it affects the differences between the black line and the yellow line here, which is for the rich. Then here, actually, increasing ordeal hurt my targeting more. Okay. Any questions so far? Okay. No. All right. So let's go to something else, right? So the rich and the poor might have access to different kinds of technology to overcome an ordeal. So, for example, in Indonesia, you have subsidized fuel, and then you can sometimes the rich would actually have the poor like stand in line for them to like wait it out and to get cheaper fuel. So in this case, let's think about like earlier we talked about standing in line for X hours times wage rate. So let's think about traveling instead, right? So suppose the ordeal is that in order to apply, you have to travel S kilometers to get B benefit. Okay, so you can walk for bus. So if you walk, your marginal cost is L. And so you multiply L with the kilometer with your wage rate. And so let me move this thing. So you could see there, that's the line that has the green dot over there and the red dot over there as your cost for the poor when they walk and the cost for the rich when they walk, right? So the differences is coming from the wage rate. And if you bus, then you have to pay V for the bus fare. So and then it costs you less per kilometer of traveling. So that's K. So you could see there with the green line and the red line there for the rich taking the bus and the poor taking the bus. Okay. So when you increase ordeal from 0 to close, this gray line here, you're improving targeting because you're affecting the poor, you're affecting the rich more than the poor. But when you get too close to far here, between the gray line and the orange line, you could see that the line for the rich, so the rich gets on the bus by the gray line, and then the poor gets on the bus by the orange line. So the marginal effect of increasing distances for the rich is actually smaller than it is for the poor. So here you're harming targeting in that small range there. Okay. All right. So that's another example of when ordeal targeting might not improve efficiency. So the last one is just, let's just change the utility function from linear to concave. And in that case, you might get curves that look like this, which is first you have the gains increasing in your wealth, and then you have the gains decreasing in wealth. And here, when you go from a low ordeal to a high ordeal, meaning from the black line to the orange line, you're actually hurting not just the rich, which is on this side, but you're also hurting the poor, which is on this green side here. Okay. So various ways where theoretically increasing ordeal may not improve targeting efficiency. So let's now go to some empirical evidence. So our question is, does ordeal help? Any ordeal at all? And then the second one is, does increasing ordeal further improve targeting efficiency? Okay, so here's an experiment that Sam talked about some earlier, which is the Alatas et al. 2016 experiment in Indonesia. So you have 4,000 households, and for 2,000 of them, 1,998, the interviewer comes to the house and then do the PMT, which Sam talked about how you arrive at those questions that they interview people with. And then from those questions, they 12% received the benefit. And so overall, about only 4% of people received the benefits from everyone that is that was initially in the sample. So they impose an ordeal by asking people to go to the office to be interviewed instead of coming to your house, right? So then the process is still the same. So you get interviewed, some of you might receive the benefits, and again, it's about like 4% total that receive the benefits. So from the people that go through the ordeal treatment, they separate this out further to increase the intensity of the ordeal. So you have a far treatment and a close treatment. So the place that you have to go to is far or close, and you can go by yourself, or you have to bring your spouse. So you have 500 people in each cell. So that's the experiment, the setup of the experiment that we're going to talk about. All right. So what's cool here is that before the experiment, they already collect consumption data. So in some sense here, you can perfectly observe AI, right? So then they are going to compare what they get from this observed consumption data with what they get with the PMT and the self-targeting. Okay. So the PMT is done the year after 2011. So by then, so the collection of the consumption data and the PMT one is separate. And as Sam says, the benefit is about 10% of the income. Okay. There's a lot of underreporting of assets in the initial interview, so you get only about 4% people being approved at the end. Okay. So the question is, who shows up? So first, what they did was they regressed the consumption against what the government could have predicted using PMT, and then and the error. So in order to break apart the consumption, which is the true AI, to the part that you can observe without ordeal targeting, and the unobservable piece, the epsilon I. Once they've broken these pieces apart, then they regress whether people show up or not against this observable and unobservable. So what you see here is that the more you, the richer you score with the PMT, the less likely you are to show up, right? So this is consistent, it's good. Another thing that they see is that there is parts that would not have been predicted by the PMT, that the more they're consuming in this unobservable part, the less likely they are to show up as well, which means that the self-selection, this ordeal, is likely to improve upon what the PMT can do. Okay, so let's see if that's true. So here are the who gets the probability of getting benefit based on your consumption. So this is based on like the true AI that cannot be observed. Okay. So here you do see that, so the blue lines are the people with the automatic enrollment, and the black lines are those that have to go through the ordeal. So what you see is that the blue lines is above the black lines on the high income area. So we do reduce type 2 error, right? We do reduce the number of ineligible people that are getting the benefit. But at the same time, so we do get people who need the benefit getting it. So there's that big bump there over here, which is the poor that is getting the benefit. But there's still the poorest that are still not getting it. So type 1A error of the poorest not getting it at all is still there. Okay, so ordeal does improve targeting. So the question is, can we improve upon this by increasing the ordeal? Let's increase the intensity of the ordeal. So this is the result of the spouse treatment. So here you have to bring your spouse to the office. So what they see is that, okay, so people are coming, people with higher income are coming less, are showing up less, which we've seen earlier, but there's no additional effect of asking both spouses to show up in further reducing the rich people that show up, right? So I'll say a little bit about why this is, right? Why doesn't bringing your spouse, which should take a lot of time and energy, and especially if both spouses are working, this should reduce the number of rich that shows up, but it doesn't here. And then another one is they change the distance. So one is close and one is far. So instead of this being the effect of far, this is the effect of close. But again, they don't see an effect. Okay, so there is no effect of increasing and decreasing the distance here. Okay, there is a picture there. So you could see that that the two lines are pretty close to each other. So by increasing the distance, I really didn't improve my targeting that much. So the question is why? Which of the three theoretical possibilities explained it? Okay, so we had, the answer is none. So let me go through them one at a time. So one possibility that we had was that the cost shocks might not have the property that we wanted. But in the paper, they fit logistic errors to it, and it satisfied the monotone hazard property. So it wasn't the shape of the cost shocks. Another question is, could it be technology? Could the rich and the poor be having access to different kinds of transportation, and therefore being able to overcome the ordeal differently? So this is possible. They have some evidence that this might be possible. But when they simulate the data and they constrain everybody to the same transport, they don't get a difference. So this wasn't driving it either. So another question is the curvature of the utility function, and they fit a linear utility function just fine. So it's not that. Okay, so what could this be? So on the spouse one, it turns out that a lot of people request exemptions to have to bring their spouse there, right? So when the government has when they have this policy of asking for the spouse, there are a lot, so people will come and say, wait, look, I just have an exceptional circumstance that doesn't allow me to bring my spouse there. Maybe he's sick, maybe he's something. And allowing them to request that exemptions end up being used a lot to an extent that they don't get a difference in the spouse treatment. Another one is in the distance treatment, they also don't get a difference. And actually, they found that by increasing the distances, they also will not get a difference because a lot of people do have access to motorized transport. And what would have created a difference would have to be doing something that is pretty crazy, like having people wait 6 hours, right? So this goes to like where theory of what kind of ordeal works meets the limit of policy implementation. So oftentimes, you might come up with something that theoretically might separate the types, but in implementation, it's just politically unpalatable. Like too many people will complain, right? So you separate people, but there will be a lot of very upset people. And so when you create exemptions for people, so they're not upset, it gets abused, and a lot of them gets used to an extent that you can no longer use the ordeal to separate types. Okay. Right. So, okay. So let me so that was on ordeal. And so let me just go into productive things that look like an ordeal, but it is actually useful.
So let's quickly revisit the kinds of error that could occur in targeting.
this first half of this talk on reducing type 2 error, which is when ineligible individuals are getting benefits. So we will now talk about how reducing type 2 errors introduce type 1 error, which is when eligible individuals do not get benefits, and type 1A error, which is when eligible individuals are not even applying for benefits, right? This is the incomplete take-up problem. So these are a table of 10 of the most well-known social programs in the United States. You can see that there is a lot of variation in take-up. For example, the take-up of the Supplemental Social Security Income Program is about 60%, while the take-up for TANF, the Temporary Assistance for Needy Family, is also about 60%. On the other hand, Medicare Part B is 96%. So that means that almost everybody that is eligible for that is getting it, while 40% of people eligible for SSI and TANF are not getting the program. So if you look at the other two columns, you will see that there is a large variation as well in targeting and complexity. For the high take-up one, you could see that targeting is low and complexity is also low, meaning the eligibility criterion is low, and the amount of paperwork one has to put in under interviews is also not very high. And on the other hand, for the other two examples with low take-up, targeting is high or medium and complexity is high. So the problem of incomplete take-up is an issue not just in the US. This table from Makanda Weir, UN Research Institute for Social Development, shows that a lot of programs that are targeted towards the poor do not reach the poor. So what we're going to do now is go through a model from Clevin and Kopchuk in AEJ Policy 2011 that explains how in designing a program, one is really trading off these various types of error. And low take-up is sometimes a necessary consequence of preventing those that are ineligible from getting benefits. Okay, so as before, each individual in the society has ability level A, and ability can only be observed by a government with noise level sigma. So this could be because the individual has language barrier or health problems, so that they don't really, they're hard to evaluate through the test for this benefits. This error is distributed with mean 0 and variance sigma squared, but we will deal with the normalized error here, epsilon divided by sigma. And the CDF of this error distribution, this normalized error distribution is P, and so because it has symmetry around 0, P0 is half. The individual knows of their own sigma, their noise level, but they don't know their realization of noise epsilon. So the difference with this model and the Alatas model that we saw earlier is that epsilon is a noise in the signal of ability. It's not a cost shock, as we saw earlier, that an individual will observe when they're applying for benefits. So when the individual applies for benefits with a certain screening intensity alpha, like you can think of that as the number of interviews or the number of forms that one has to fill in, they suffer the transaction costs, F alpha. So the more complex screening is, the higher the cost function, the higher the cost is for the individual applying. So the reason why the government might want to increase screening intensity is in order to observe the ability signal better. So alpha prime, what the government observe is A plus the noise divided by the screening intensity. Okay, so the government has the following policy instrument. We'll talk about 3, and before I go through them, let's just for simplicity assume that there are 2 types, the low types, the poor types, and the high types, which are not poor. And the government has a budget of R and seek to give out benefit of at least B bar to as many low types as possible. And he has 3 policy levers. One is the screening intensity, which we saw earlier, alpha. The higher alpha is, the higher the cost to the applicant, but the lower the noise. A bar is the strictness of eligibility criterion. So for example, this will say you need to have a minimum income of $13,000, maximum income of $13,000, kind of A bar. And if you observe, if the measured A prime is smaller than A bar, the applicant will receive B. Last, we have the size of the program benefit B. The higher B is, the larger utility one gets out of applying to the program. Okay, so in short, the government is maximizing the number of load types that it can reach by using these 3 policy levers, subject to the total cost of the program meeting its budget constraint. Okay, so now how does this policy levers affect an individual? First, the threshold will interact with the complexity. So one person will get a benefit when they draw errors that are small enough or negative enough such that their measured ability passed the threshold. So we can rewrite the probability that an individual will apply as a function of the CDF of the error. Okay, so that's that red part over there. So it's a function of the CDF, the threshold A bar, and complexity alpha. So now let's think about how the benefits enter. So an individual will apply when the probability of getting the benefit times the benefit plus the probability of not getting the benefit times what they get, if that happens, is larger than not applying. So if we rearrange this, we can see that a policy of a certain complexity and a certain benefit size will set a threshold probability such that if the probability of getting the benefit is less than this, it is not worthwhile for someone to apply. So together, the 3 levers will interact in the individual's decision as follows. An individual of ability AI and precision sigma I will only apply if their individual probability of getting the benefit is larger than this threshold probability, which is determined by the complexity, which determines the transaction cost, and the benefit size, which determines the utility of applying. So we can now see how the strictness of the eligibility criterion will affect who applies. So I put the statement for the last statement in the previous slide here, just for us to remember. So let's look at how A bar affects who applies. In the case we set A bar at a strict level, which is A bar is lower than the low types and the high types, when there's no noise, nobody will get it. Nobody will get the benefit. And so in this case, only individuals whose signals are very imprecise will be applying. So take up here will be low among low types that have precise signal. Another place we can place A bar is between the low types and the high types. So here, when there is no noise, when everything's very precise, the low types should get it and the high types will not. In other words, we will be able to get full separation. However, with noise, the most precise low types will be applying, and the very imprecise high types will also be applying. So this full separation setup seems like an attractive setting, but Cleveland and Kupchak shows that this result still introduces a substantial type 1b error, which is eligible applicants will not get benefits with a pretty high probability. And this problem can be alleviated by reintroducing a little bit of type 2 and type 1a error by setting the threshold at a more lenient level. So in the case of a lenient threshold, we set A bar above or at AH. And here, if there was no noise, everybody will be able to get the benefit. The high types will get the benefit with noise. The high types will be able to get benefits with at least probability half, and the low types will get it with an even higher probability. And the more precise you are, the more likely you are to apply. And here, the type 2 error will return. And so if you want to reduce that, you would want to increase complexity and reduce benefit size, which will then again reintroduce type 1A error of incomplete take-up. In summary, the trade-off between targeting error and the trade-off between the various kinds of targeting error that we see is part of the policy design for targeting the poor with benefits. As complexity increases, type 1B and type 2 error decreases because we can see the signals more precisely. But type 1A error increases because the cost of applying now is higher. Note that in this model, pure ordeal, as we talked about earlier, will be simply an additional term added to the transaction cost. And so it does little to reduce noise. So it's doesn't help targeting that much here. The other policy lever, the program benefit, also has to affect. As the program benefit increases, type 2 error increases because it's more attractive now to apply for the benefit. But type 1A error decreases because those that, the low types will also be more likely to be applying. So that is all that I have for self-targeting. Thank you so much for attending this session 1B. And I hope to see you guys soon for the next session. Thank you.